Okay, welcome to our practical session. The aim of today's experiment is to determine the mass of spring and acceleration due to gravity by using oscillating mass attached to a spring, to a spiral spring. Aim is to determine the mass of spring and acceleration due to gravity by using an oscillating mass attached to a spiral spring. Now this is our spiral spring, okay, and this is a normal rheostat. We will be using several masses, as you can see in the table of result here, starting with the 100-gram mass, this one. According to the procedure in the question paper, we're going to start with the 100-gram, and then we'll make an oscillation for 30 time. We'll record the time for 30 oscillations. Okay, we'll be using a stopwatch as usual to count those 30 time, to record time for 30 oscillations. Okay, now I'll fix 100 mass here on a spiral spring, as you can see here. Now we are told to oscillate, to record time for 30 complete oscillations. Okay, now to start with, just small oscillation. Okay, according to my stopwatch, time is now 11.56 seconds. That is time taken for 30 complete oscillations. That is vertical oscillations. Okay, now let us see time for when mass is now 200 gram. Let us see time taken when you oscillate on vertical oscillation. Okay, just small amplitude. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 17, 18, 19, 20, 21, 2, 3, 4, 5, 6, 7, 8, 9, 30. Okay, according to my stopwatch, time is 15.97 seconds. Okay, now let us see time taken for 30 oscillation when mass is 300. So I'll just add another 100 here. Okay, now let us start counting time when mass is now 300 gram. Let us see time taken for 30 oscillations. Okay, just small amplitude. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 26, 27, 28, 29, 30. Okay, according to my stopwatch, time is now 19.32 seconds. Okay, now let us see time taken for 30 oscillation when mass is 400 gram. Mass is 400 gram now. Okay, now let us count. Okay, just you apply just small amplitude, then you release. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 3, 24, 5, 6, 27, 28, 29, 30. Okay, according to my stopwatch, time is now 22.37 seconds. Okay, now let us see time taken for 30 oscillation when mass is 500 gram now. Okay, Okay, just apply vertical oscillation as usual, small amplitude, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 2 3 4 5 6 27 28 29 30. Okay, according to my stopwatch, time is 24.93 seconds. Okay, now lastly, let us see time taken for 30 complete oscillation when mass is now 600 grams. 600 grams, as you can see here. Okay, as usual, we'll count 30 oscillation and then we'll record the time. Just apply small amplitude, 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25 26 27 28 29 30. Okay, according to my stopwatch, time is 27.19 seconds. Okay, now let us complete our table to fill the periodic time. That is, periodic time is equal to time taken over number of oscillations. Now for our case now, we divide 11.56 divided by 30, so that is now 11.56 divided by 30, you get 0.339. Okay, this now is 15.97 divided by 30, 97 divided by 30, we get 0.53 second. 19.332 divided by 30, you get 0.64. 22.37 divided by 30, we get 0.75. Okay, 24.93 divided by 30, we get 0.83 second. Okay, 27.19 divided by 30, we get 0.91. Squaring this one, square each to get periodic time, we square this one, so it's 0.39 squared, we get 0. Approximate 2 decimal place, that's 0.15. 0.53 squared, we get 0.28. Okay, if you square 0.64 squared, get 0.41. When you square 0.75 squared, we get 0.56. When you square 0.83, we get 0.69. When you square 0.91 squared, we get 0.83. Okay, we are done with table of result. Now let us see the question paper. Question paper says that plot a graph of M against, that is D. Plot a graph of M against T square, So now let us plot a graph of M against T square. That is, this mass is here, load M against T square there on the table of result. Okay, now we have already plotted a graph of mass against time square. That is a graph of M against T square. Graph of M against T square, as you can see. Okay. Nature of graph seems to be a straight line, as you can see. That is M T squared. The graph cuts just a bit down somewhere here. Okay, M intercept somewhere here, as you can see. Okay, this one here. Right, now according to a question paper, we are told to find a slope of a graph. Okay, find the slope M equals to change in M, this one in gram, over change in T square, this one in second squared. Now according to our graph, points are on M axis, that is 650 minus 425 over, on T square axis, that is 0.90 minus 0.60 minus 0.60. So this is in gram, this one in second squared. So we get 225 gram over 0.30 second squared. Okay, we get around 750 gram per second squared. So this is the value of a slope. Okay, now that was E. Okay, that was E, slope of a graph. Now according to the question paper, we are told to determine intercept on M axis. Okay, intercept on M axis, that's Y axis. This one is here. If you can observe carefully, according to a graph here, you see it is somewhere here, just close to 0, but below 0, just below 0. So according to our scale now, the intercept is approximately 10 gram. If you calculate using the scale, you find intercept on M axis is 10 gram. Okay, that is the value of the mass spring, the mass of our spring, the value of a mass of a spring. Okay, now let us see F, that is F here. Given that T equals 2 pi under root of m plus m naught over kg. So now let us make subject m in this equation. Making m subject here, we say that mt is equal to 2 pi under root of m plus m naught over kg. If you square both sides, if you square, you get t square equals to 4 pi square m plus m naught over kg. Okay, t square equal to, open the bracket, that is 4 pi squared m plus 4 pi squared m naught. This is over kg, both over kg. Okay, 4 pi square m over kg equals to t square minus 4 pi square m naught over kg. Now multiplying by kg on both sides, that is to say kg times kg. Okay, if you multiply, you get this one cancels, that is 4 pi square m equal to kg t squared minus 4 pi squared m naught, because this one cancels with this one. Okay, dividing by 4 pi square, both sides, 4 pi squared, 4 pi squared, this one cancels, this one cancels. So finally we have the value of m, that is m is equal to kg t square minus m naught over 4 pi squared. So now when you relate this equation with the equation of straight line in mathematics, now it resembles y equals to m minus c, mx minus c, y equal to mx minus c. That is to say, intercept here is corresponding to c here, and that is the whole constant here, this one here is corresponding to slope, and the value of t here is corresponding to x, and this one corresponding to y. So we say slope m is equal to kg over 4 pi square. Our intercept here is minus c equals to minus m naught, so this now become positive now. So we say therefore c equals to m naught. So we get the value of, mass of a spring from the intercept, as we see in the graph. That is, the value of m naught is here. You get it from the intercept, m intercept. The value of m intercept equals to m naught, that is mass of spring, which is approximately around 10 gram. Okay. Last question says calculate the value of acceleration due to gravity. Okay, now we have to determine the value of acceleration due to gravity and spring, mass of a spring. But already we have mass of a spring, that is mass of spring M naught is, we say that is now approximately 10 grams from the graph, and acceleration due to gravity, acceleration, the value of acceleration due to gravity that is G can be obtained from the relation here, from this slope. As you can see here, we have the value of slope already, and the value of K is given. So from that equation we say that slope M equals to kg over 4 pi squared, but K is given, that is K equal to spring constant, that is 30 gram per centimeter. This value is given, and the value of slope we have M equals to 750 gram per second squared. Okay, so now we say 750 gram per second squared equals to K is 30 gram per centimeter times G over 4 times pi, that's 314 squared. So 3 gram per centimeter times G equals to 750 times 4 times 3.14 squared. So dividing by, this is in gram per second squared unit. Okay, now dividing by 30 on both sides, 30 gram per centimeter, 30 gram per centimeter. So this one cancels. Now G equals to, now that is 750 times, okay, let me start here, 3.14 squared times 4 times 750, we get, okay, that is divided by 30, the value is 985.96. This one cancels with this one, so we remain with centimeter per second squared. So the value of G now is, you can convert this one into meter now, into meter per second. Okay, how do you do that? Let us convert this one into meter per second square. So we get, therefore, say acceleration due to gravity G is equal to 985.96 centimeter per second square. You can convert this one into meter by multiplying or by dividing by 100. So you can just divide by 100, take care of the units, that is now 9.8596 meter per second squared, approximately 9.86 meter per second squared. So we are done. That's the end of our experiment. Thank you.